Okay, so next we're going to look at graphing linear equations, and we're going to look at graphing linear equations in standard form. And remember, this is our standard form. So plotting all solutions of the linear equation results in the graph of a straight line. So I kind of spilled the beans of that conclusion in the previous thing pair share. So every point on the line is a solution of the equation. So every point on the line is a solution of this equation. And every solution of this equation is a point on the line. So, here we've got this think pair share. All right, so we have this think pair share. And I'm intentionally kind of blocking the bottom half because I've already written in the solution for this. So this is graph solutions of minus 2x plus y equals -3. So use the previous example as a model. Go ahead and pause the video and come back after you've plotted some points, and we'll resume. All right, so go ahead and pause. Okay, so let's take a look, at what I did, and you can compare this to what you did and some of the extra notes that I've got in here. So again, we're trying to graph solutions of minus 2x plus y equals -3. So I just kind of rewrote this equation here. And so one possible one I thought of is, what if x is equal to 0 and y equals -3? So you can see if I put 0 in for x and -3 in for y, this will be -2 times 0 is 0, and -3 equals -3. So that's true. So this ordered pair, 0, -3, is a solution. And so because it's a solution, I can come over here to my graph, my Cartesian coordinate plane, and I can plot this point 0, 3. Okay, now we've got if x is equal to +1 and y is equal to -1, then -2 times 1 plus -1 equals -3. That will be true. So the ordered pair 1, -1 is also a solution. So I can come over here and I can draw it. Let me put this in green to kind of make it stand out. So right here is the point, and that's the point 1, -1. Right, and then I thought, well, if x is equal to 2 and y is equal to 1, that should work, because -2 times 2 plus y equals 1 does give me -3, so that's true. So this point 2, 1 is also a solution. So I can come over here and plot the point 2, 1, and that's a solution. So you should start to see that these individual points, these individual solutions are lining up. Okay, and that's why it's called a linear equation. Okay, it's called a linear equation because the graph of a linear equation is a line, right? That's kind of how that came from. That's how that got derived. So I just kind of picked 3 points just to kind of show a trend that's happening here. And, I went ahead and drew this, this pattern that the lines are forming, kind of up and to the right and down and to the left. And then I just kind of wondered to myself, your note, I'm limiting myself to small values of x and y. So I'm looking at values of x and y that are like 1, 2, and 3, because it's easier to do smaller numbers, in my head. And then I said, if only there was another way, I wonder. Okay, so we'll kind of be getting to that idea here in a minute. So note, we are trying to guess both values of x and y. Okay, guessing is going to only get you so far. But what we can do is we can actually find x and y intercepts for our linear equation. So for example, if x is equal to 0, what would y need to be? Right? So I accidentally found the y-intercept up here. So if x is 0, what do we get for y? We get -3. So this point 0, 3, okay, that was our y-intercept. So that was this one right there. Right? Now, what if y was equal to 0? Okay, what would x need to be? So this is part B. So I put part B here. So if y equals 0, then what's x? So what we can do is we can take our linear equation in standard form and put 0 in for y. And now that we've got one equation with one unknown, x, we can just now solve for x. So we get -2x equals -3, divide both sides by -2, and negative divided by negative becomes a positive. And so we get x equals 3/2, which in decimal form is 1.5. So that in turn will give us this ordered pair. When x is 1.5, y is 0. And that is our x-intercept. So come up here, and you can see I plotted it in green. Here's our x-intercept, and it's this point right there on 1.50. That's our x-intercept. So what's nice about plotting x-intercepts and y-intercepts is that you can just go ahead and put in 0 for y or 0 to x, and anything times 0 is 0. And all you need to plot a line, to graph a line, is you just need 2 points. So x and y intercepts are really convenient when it comes to graphing linear equations. Okay, let me know if you have any questions.